Alright, this is a water table, and it represents what happens in real life with our wells. Like, for example, we have pumping wells, 1 and 2, we have some other ones over there, and around them are the piezometers. Piezometers are kind of like wells, except they don't have the same kind of structure. They're not as, they don't have regulations or anything. They're just used to measure the water table. So you can see, like, when you pump water out of well 2, you look at the piezometer, and if the piezometer is low, it means you're pumping either too much water or there's not enough water to pump out. And this represents, this would be like a river going through the ground, and you can see how it shows like pumping water out of around here will affect the river and how the water moves through right here. And this is just a good representation of how our wells are and what we have to deal with. Alright, Carter went here, and I'm going to talk about concept number 1, the recharge. So first you're going to get water, you're going to pour it in the recharge area right here, and you're going to watch how the water starts from right here and slowly drifts across. The water moves a lot faster through these parts with the bigger rocks because there's bigger pore spaces, so the water moves across a lot easier. You can see in the dye, the red dye shows that it travels through easier.
Well, is the texture of materials is in the aquifer affects the rate and the flow through the aquifer. So in this model, the rocky surface has a lot of airspace, so the water can go through faster, whereas in the sand, it doesn't have as much airspace, so it goes through slower, whereas in the confining layer, it's too thick where the water can't travel.
Step number 4, it's when we pump water from well number 2, which is an unconfined aquifer. It's easier to access because it's closer to the surface. And this is a good representation of how they pump well water for farm animals and houses and drinking water in real life.
We're talking about adding dye to our groundwater model and how it shows the water movement. So, as you can see, we have dye in both the recharge areas, and what that does is it distributes the dye with the water. So it has colors so you can actually see where the water's traveling. So right here, it's like a really concentrated area because the pore space is so large, so it's really red. And as you can see, in different areas, it's either green or red, depending on what kind of dye we added. And it shows how the water moves throughout the model. And yeah.
1, 2, 3.
We're dealing with concept number 9, the artesian aquifers, and when it's under pressure, the water levels begin to rise, and then it spreads out through all the water table.
Nope.